I'm here to tell you 4 things. The first is that global warming is happening. And not only is global warming happening, but it's already increasing the risk of high-impact extreme events. And the risk of going along the current trajectory, the business-as-usual world that we're on, is much greater than if we find a pathway towards a carbon-free energy economy. But we have a big challenge, because the reason that we have global warming is the side effect of energy consumption. And that energy consumption confers tremendous benefits. And there's huge energy poverty in this world. And that is fundamentally our grand challenge. But there's hope, because we, right here at Stanford and beyond, can be the engine of innovation that figures out how to create a world that ensures energy access to all people on Earth while minimizing the impacts of climate change. So global warming is real. It's a measurement. It's an observation. It's big data. This is the record of temperature going from 1850 on the left up to the present on right. And what you see is there are variations from year to year. There are variations from decade to decade. You might see periods where there appears to be a pause or a hiatus, a slowdown. However, unequivocally, from direct observations, we see the trend. This noisy series has been tilted on a trend, and that is global warming. It's not a matter of debate. It's not a matter of belief. If you believe in thermometers, you believe in global warming. And what this global warming is doing is not only creating this global trend, but it's already increasing the likelihood of high-impact extreme events. And we feel the stresses of the climate system day after day, year after year, decade after decade, here in the US and all around the world. We see it in billion-dollar disasters here in the United States. We see it in many other examples across the globe, in the oceans and on land. And we know from observing the climate system, from direct observations, that the likelihood of extreme events is already increasing. We see this with severe heat. We see it with heavy rainfall. We see it with extreme storm surge that happens in a landfalling storm. We know that the sea level rise that's already occurred has already increased the likelihood of extreme storm surges, just like what happened in Hurricane Sandy. We also know that the global warming that's occurred has resulted from the human emission of greenhouse gases to the atmosphere, primarily carbon dioxide. And what you're seeing here, each little dot is a year. These are real observations, real data of the last 25 years. And when we look out over the whole industrial era, 25%, a full quarter of the historical emissions have come from the United States, and another quarter has come from Europe. And in the last 25 years, we're seeing a ramping up in emissions. In fact, the total global emissions have doubled on an annual basis over the last 25 years. And if the world continues along this business-as-usual trajectory, we're likely to see global scale warming of around 4 degrees Celsius. 4 degrees Celsius is twice the level of global warming that's been identified by the international community, by the United Nations, as being the safe target for constraining climate change. And every year that we continue along this business-as-usual trajectory, the window for constraining global warming to that 2-degree target gets a little narrower. But the window's not closed yet. It's still open. Okay? And we know from arithmetic and the basic physics of the climate system that a sustained trajectory towards a carbon-free energy economy over the next half-century can ensure that the world stay below that 2-degree level of global warming. So you're going to hear me talk for the next few minutes about this 4-degree world that goes along the red line, this business-as-usual trajectory, and a 2-degree world that goes along this blue line towards a carbon-free energy economy. And the stakes are real, because there's a big difference in the risk of climate change between the 4-degree world and the 2-degree world. And I'm going to show you a few examples of the differences in those risks. And the first is extreme heat. And extreme heat is where we really feel the stress of the climate system in a lot of different sectors. And what we've done is we've looked back at the recent past and we've asked for every part of the world, what's the hottest season that occurred in the late 20th century? What was the most extreme year? And then we've looked out at the 4-degree world and we've looked out at the 2-degree world. And what we find is that in the 4-degree world, what used to be the most extreme year, the hottest, oh my goodness, this is outrageously hot year. In the 4-degree world, that level of heat happens pretty much every year, pretty much everywhere on Earth. 80, 90, 100% of the years experiencing that extreme heat. And that risk is substantially reduced in the 2-degree world that the UN has identified. Similarly for extremely low snow years. Here in California, about a third of our water is dependent on Sierra snowpack. And more broadly in Western North America, our water resources are highly dependent on the natural reservoir that's provided from snow. And right now, we're in the midst of an extremely low snow year, as Governor Brown pointed out in this photo in January. And when we look out again along that business as usual pathway, what you're going to see is an animation just marching forward along that red line that I showed you. And the colors are showing the fraction of years where the spring snowpack falls below what used to be the lowest year. And what you see as we walk along this warming is that in the 4-degree world, the extremely low snow level becomes common. In Western North America, 40 to 80% of the years experiencing the extremely low year. Another area where we're already seeing impacts here in the United States and around the world is in agriculture. And in California and in the Western United States, one of our highest value, most iconic crops are premium wine grapes. And we know that this global warming that's occurring is not only affecting the temperature in different regions, affecting the rainfall in different regions, but in particular, it's affecting crops that have very narrow climate envelopes, and premium wine grapes are one of those. And in our work, we found that along this, even the 2-degree pathway, over the next 3 decades, we're likely to see decreases in the suitable area throughout the Western United States where we currently grow the highest value, highest quality wines. And in Napa County, what we're projecting is greater than 40% reduction in suitable area over the next 3 decades. So these are the kinds of impacts that we're facing. The impacts from severe heat and extremely low snowpack that I've talked about, impacts from heavy precipitation, impacts from sea level rise that increases the level of storm surge that happens during landfalling storms, increased volatility of crop yields, which as they make their way, those supply side shocks make their way through the economy, increase the volatility of crop prices, changes in the landscape of suitable climate for growing different crops. Looking at natural systems, we're now seeing in the literature scientific evidence over the last few years that the rate of change at local and regional scales is likely to be faster than what many species can keep up with. And if we look off of the land into the ocean, we're likely to see impacts not only from warming of the waters, but also acidification of the waters that comes from increasing CO2. And one of the key challenges for dealing with the impacts of climate change is that rate of change. Because what we're facing in the 4-degree world is a rate of global scale warming that has not occurred in the last 65 million years since the extinction of the dinosaurs. So we know that the current concentrations of carbon dioxide, the 400 parts per million that are in the atmosphere right now, are higher than at any time in the last 800,000 years. Scientists know this from direct measurements of gas bubbles inside of ice. We also know, looking at other geologic proxies, that if we look back further, that the current concentrations, the 400 parts per million, are higher than has occurred for most of the last 20 million years on Earth. And what we're facing along our current trajectory, our business as usual pathway, the world we're in now, is more than a doubling from 400 parts per million to 800 parts per million and beyond. And the 4 degrees of warming in a century that will come with that is at least 10 times faster for global scale warming than anything we can find in the last 65 million years. An unprecedented rate of global scale change. And if this business as usual pathway, this red line that you've been seeing, the 4-degree world, if we continue along that pathway to the ultimate conclusion of combusting all of the fossil fuel reserves that we know about, the simple arithmetic of the amount of carbon in those fossil fuel reserves means that we'll be looking at a world, we'll be experiencing a world with carbon dioxide concentrations that are many times higher than anything that we know about in the last 65 million years, persisting with high levels of global warming for millennia. And so our fossil fuel-based economy, from which I derive tremendous benefit, the fossil fuel-based economy that has been the engine of human development, creation of wealth, this creates tremendous inertia towards further global warming. And it's one of many sources of inertia. There are physical sources of inertia in the climate system. There are many political sources of inertia that we can think about. But by far, the strongest, most powerful, most important source of inertia that creates momentum towards further global warming is human well-being, and most importantly, the lack of human well-being and the requirement of energy for increasing the level of human well-being globally. And this is seen poignantly in this photo. These are college students in the Republic of Guinea, and they're at the airport. And they each have their bollard, and they're studying underneath the lights at the airport. They migrate in the evening to do their work because their homes lack electricity. And this is the challenge that we're facing because we derive tremendous benefits from energy consumption. And the lack of energy access, energy poverty, it creates tremendous vulnerability. It limits human development. And we see this in the billion people that lack access to clean drinking water, the 2.5 billion people that rely on biomass for cooking, and all of the indoor pollution and health effects that come from that. About 1.5 billion people that lack electricity. These are fundamental limits to human well-being. And in terms of climate stresses, the lack of energy access creates tremendous vulnerability to heat waves, flooding, drought. And so this ultimately is the grand challenge, because if we look across all the countries in the world, and what you're seeing here, each diamond is a country. And the level of human development index is on the vertical axis. And on the horizontal is the level of per capita energy consumption. And what we see is that all of the countries in the world that have achieved a high level of human development, a high level of well-being, they all consume a lot of energy in the per capita. And so the real question for the next century is how is the world going to ensure energy access? Is it going to look something like me? Is the rest of the world going to follow the pathway that the United States has followed? Because if we do, that's the equivalent of adding 15 United States to the global emissions total. 15 more United States year after year after year. And that gives us more than a 50% chance of going along that red line, exceeding 4 degrees of global warming, a rate of global warming that's unprecedented in the last 65 million years. And you might say, why the United States? Why pick the United States? The United States isn't so efficient. Well, even a more efficient, lower consuming, lower carbon intensive profile such as Japan still gives a 90% chance of going beyond the 2-degree target. So this is a daunting challenge. The 15% of the global population that lives in the most highly developed world, we account for 85% of the global emissions. And it's a daunting challenge to deny that access to energy consumption to the rest of the world, to the other 85% of the population. But we have hope, because the arithmetic tells us it is possible that if the world converges on a carbon-free energy economy, we can still ensure access to energy consumption globally while also achieving the 2-degree target. And that's where there's hope. Because we here at Stanford, in Silicon Valley, in California, we can be the engine of innovation. And we need that innovation. We need to capture all of the creativity and intelligence and hard work that have made this place what it is. And we need to figure out a way to provide the example and the technology transfer, the behavioral transfer, all of the effort that it's going to take to design urban systems, agricultural systems, the public policies that are required to make all of this possible. And I often get told I'm a real downer, that I'm peddling this depressing view of the future of the world. But I have hope. I have hope. And this is a picture of where I grew up. This is my home. It's a beautiful place. And I believe that we can create a world where every person on planet Earth has access to the same level of well-being that I enjoy, but do it in a way that still preserves something like the climate system that we have now. And I believe that we right here in this room, here on this campus, here in this wonderful state, that we can be the laboratory, we can be the engine of innovation, and that's what gives me hope. So thank you.